All right, this is State of Global Forests B. Before we go on, I wanted to add a few important definitions from the FAO related to the dynamics of forests. So these are deforestation, which FAO defines as conversion. This is an important word. Of forest to another land use. Or long-term reduction of canopy cover below 10%. Because remember, FAO's definition of forest is it has a canopy cover more than 10%. So generally deforestation means cutting down forest and then converting that land to some other use, often agriculture or development. But it could also, with this definition, include just degradation of forest to the extent that the cover is reduced below 10%, and it's just sort of a degraded forest with relatively low canopy cover. So that's deforestation. Reforestation is reestablishing forest through planting or deliberate seeding. And I would go ahead and add or natural regeneration, so allowing natural regen from residual trees on land already classified as forests. Okay, so this is land that's already forest, and you're just planting or allowing to regenerate forest in that area where, for instance, you've cut down trees. So that's reforestation. That allows the land to continue as forest. Afforestation is a conversion, but rather than conversion from forest to another land use, it's conversion of land that has not been forested for 50 years. So that's sort of an arbitrary length of time. To forest through planting, seeding, or natural regeneration. So allowing existing trees to seed in a forest with canopy cover greater than 10%. So those are some important definitions to keep in mind. This graph shows changes in net forest area or net change by decade. So the 90s, the 2000s, and 2000 teens. So really, this net change is basically, deforestation plus any offsets by afforestation. So deforestation is removal of forest. Afforestation is adding forests. Reforestation wouldn't really figure into this because reforestation just keeps the amount of forest the same. So over time, what you can see is that in each of these decades, there's a net loss in forests. In the 90s, there was almost 8 million hectares per year lost in net forest cover. 5.2 million hectares per year lost in the 2000s, and a little bit less than 5 million hectares per year lost in the teens. So while there's still a net loss of forest every year, the rate of forest loss, the rate of net deforestation has gone down over time. So overall, on a global scale, that's a good trend. When we look at this trend spatially, we see that deforestation, that net forest loss, is really occurring primarily on really only on two continents, Africa and South America. So these graphs show both space, these continents, but also time. So the different bars, colored bars within each continent show the 90s, the 2000s, and the 2010s. So what you can see is that South America, and Africa have had net losses in forest each year, while North and Central America have basically remained steady. I would say that Oceania, East Asia and the Pacific Islands have also remained steady, while there's been net growth of forest, especially in Asia. This is probably, I would say, dominated by planted forest in China. Big efforts to afforest sites in China. Just a reminder that conversions in land use are driven mostly by economic or political social factors. So disturbances, horrific fires in some places can cause land use conversions, but for the most part, land use conversions are primarily economics. We talked about that in the United States. We talked about forest changes, but they can also be politically or social. So this is the example of Brazil and Brazilian rainforest in the Amazon rainforest. So Jair Bolsonaro was elected Brazilian president in 2018. Big part of his platform was economic development through the use of Amazonian rainforests. So that political movement basically accelerated the clearing of Brazilian rainforests, primarily for cattle ranching. Those conversions also led to increased risk of wildfires. It's important to note that countries are sovereign. That means they get to determine what happens to the forests within their boundaries. So, Brazil and their political system has control over Brazilian forests. But it is important to remember that forests in general have global impacts. Forests regulate climate. In Brazil, the Amazonian rainforest is a significant factor in carbon uptake and storage from the atmosphere, and that Brazilian rainforest is very diverse. It's a source of biodiversity. About 10% of the world's plants and animals exists in those forests. So while the use and fate of forests are really determined at the national level, the implications of any of those changes really are global. And it is important to remember that once some forests especially are converted to other land uses, it's difficult or impossible to get them back. So for instance, some Brazilian rainforests have species richness on the order of 250 trees per acre. So that's a lot of species per acre, and you would be hard pressed. I mean, I would go so far as to say it would be impossible to artificially reestablish a forest with 250 trees per acre. So some of these land use changes and forest conversions are essentially permanent and irretrievable. There are different types of forests, and one way to categorize forests is whether they are naturally regenerated or artificially regenerated or planted. So here are, definitions. Naturally regenerated forests are there. They regenerated from seed from trees that are in that area. Whereas planted forest obviously is planted of seed or seedlings by humans. In general, there's been a loss of naturally regenerating forests. So in all of the last 3 decades, there's been a reduction in sort of the amount of forest in this category. And that loss can occur through conversion or deforestation. So for instance, if a naturally regenerating forest was cut down and then converted to agriculture, that would show up as a loss here. But it could also be or conversion to planted forest. So it could be that a naturally regenerating forest is cut down, but then trees are planted in that location. And that would basically be, a conversion from here to here. So what you can see is that in all of those 3 decades, there's been about, 3 to 5 million hectare per year increase in the area of planted forests, and 8 to 12 million hectare decrease in the area of naturally regenerating forests. Just for context, it is important to remember that globally, 93% of forests are naturally regenerated. So still, the vast majority of forests are in this category. Plantations only are 7% of global forests, but this gives you the sort of magnitude of change of those. This is interesting data regarding planted forests. So globally, when you look at that 7% of world's forests that are planted, about half of those planted forests are planted with trees that are native to that region, and about half are planted with trees that are not native to that region. So those are introduced. So non-native and introduced are equivalent terms. And this varies widely by continent. So, for instance, in North America, only about 3 or 4% of planted forest are planted with non-native, introduced or exotic species, whereas 96, 97% of planted forest are planted with native species. So Douglas fir, the southern pines, spruces up in Canada. So North American forestry is a little bit unusual globally in that most of the planted forest and therefore the industrial forest uses native species. In other places like South America, the vast majority of forests are established with introduced species. What those species are varies from continent to continent, but I would say the most common introduced species planted worldwide are eucalyptus species. Eucalyptus is a genus of tree species that are native to Australia. There's actually hundreds of eucalyptus species, but some smaller number of those species and their hybrids are planted all over the world. Some other important species, radiata pine. It's actually native to coastal California, actually a few counties in coastal California, but it's very broadly planted across the globe. Very common planted species. Other fairly common species that are planted outside their range for commercial purposes are U.S. southern pines. So you can go to China or South Africa, some countries in South America like southern Brazil, Chile, Argentina, and see loblolly pine, slash pine growing there. So the U.S. southern pines are important. Douglas fir is a common planted species in, for instance, New Zealand. In some European countries, Sitka spruce, which is native to the Pacific Northwest, U.S. and southwestern Canada, it's planted in, for instance, Scotland as a non-native plantation species. So non-native species are very commonly established as planted species. And there's a whole reason and rationale for that, but we're not going to go into that right now.